From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Well, thank you much for the introduction. As we've just mentioned, I myself am Mirza Kopic from SAP, and then with me, of course, I've got Marvin Beckers. And we wanted to talk to really about what exactly the platform mesh is. But before we do that, let's first sort of jump into a little bit about NeoNephos. A bit of an introduction is necessary here. So NeoNephos emerged as an outcome of the IPCEI-CIS, this important European cloud infrastructure projects. And it's there really to foster European digital sovereignty. It's a foundation, it's a neutral home for open source cloud edge continuum projects. That you can imagine, that have different parts in the continuums that want them to participate. And we, of course, make all of those projects open source, and everybody is invited to collaborate and join us to contribute as well. But the key takeaway here is it's not a single product. Okay? It's not a monolithic product. These are modular components that you can mix and match for the cloud edge continuum. So there are specific problem spaces that you then want to solve, and there are projects that then try to address those spaces. Of course, here are some of the projects that we can see, and we're primarily focusing today on platform mesh, and where we sort of look into this concept of how do we solve this problem of interoperability between many different providers that come from many different platforms, potentially, and how then to combine them into one unified approach. But we also eat our own dog food. We use our own other projects as well. We use the open component model, which is a way then to package artifacts and then bring them into environments and ecosystems with their dependencies as well. We also use OpenMFP, which is the open micro frontend platform. So if you have a KRM, you have some sort of Kubernetes API, and you want to bring a UI to make that user experience a little bit more intuitive for users, then you wouldn't use this frontend. And it's exactly what we also then do in our platform mesh instances as well. Now, with that said, I wanted to talk a little bit about this cloud edge continuum. Now, the cloud edge continuum, just on a high level, is really just a computing architecture that defines the strengths of cloud computing, and edge computing. But it has a bit of a problem per se with this. Let's call it a challenge, really. These are heterogeneous resources with diverse computational capabilities, across different administrative domains, and that's a key point here. But when you sort of say, well, that's the continuum itself, when we look at it from a more coarser point of view, we actually see that we can divide this into two sort of ecosystems. We have the north and the south ecosystems. We have the software providers that always want to be flexible and available to you. You're the consumer in the end. You're the application developer who says that I need to have services and I need to have software that enables me to build those applications on top of those services. But at the same time, though, you also have these infrastructure providers. The problem, though, with the infrastructure providers is that, contradictory to the software, they're not flexible and mobile. The infrastructure providers, they aim for lock-in and control. By design, unfortunately, that's how it is. So these two ecosystems play together, but have many different commercial objectives, okay? And this leads to the vendor lock-in problem. You have these proprietary APIs. Each provider speaks their own language. There is no single defined open API for connectivity. There's no standardization per se. So there are these vendor dependencies. Switching between providers means rewriting integrations for the consumer. So you should also have this issue of skill fragmentation. Teams need to be specialized in each of the providers' ecosystems. And you have a bit of an innovation barrier as well. Imagine you're a small European provider that can't compete with these established larger ecosystems because you want to bring in your own opinionated weight into it, and it's very difficult to do so. As a matter of fact, we were just talking about that just before. Now, this isn't necessarily a technology problem, from my point of view. I want you to think about it rather as a standardization problem, and that the infrastructure exists, but there's no common way to use it effectively. And even if I wanted to sort of step in a single provider in this large continuum itself, when we look inside it, we see something interesting. So let's see a way of how we can maybe define a way then to understand this a little bit better. When you look at your typical definition of a cloud stack, okay, you have these rigid silos, these artificial barriers that necessarily depend on the layer below. They are tightly coupled to each other. So whereas each layer is then also controlled by the provider itself. Your mileage may vary of a typical stack, but this is pretty much a definition when you look at it, a very simplified approach of it. I know the definition slightly has been updated since then, but that's the idea. But these artificial boundaries, they need to be overcome, okay? So then these providers then says that, well, I don't want you to introduce that complexity to you. I am going to provide you with my own opinionated administrative management API, whatever you want to call it, to manage these specific services in these components in that stack. Okay, and you can then make use of those. But you see that they have to do some patching, they have to do some gluing, they have to do some bridging between these different layers that they want to bring into this management opinionated API. So they try to say that, well, there's these diverse components into a cohesive platform where the APIs create a vertical integration from the business logic to the infrastructure. Now, coming back in the context of the multi-provider cloud edge continuum, we see then, with this in mind, when you look even at the larger level, not the microstructure, but the macrostructure of across providers, you have all those similar challenges. You have incompatible APIs across those providers. You have increasing exponential complexity. If I am subscribing to provider A and I'm subscribing to provider B, I have to understand both of their opinionated APIs to be able to make sense for my own needs. So this leads to these proprietary lock-ins and these vendor interfaces that you then have to communicate across. So there's no consistent way across this continuum for consumers. And then when you really look at it, you say, like, well, what I just mentioned before is that I have a provider A and I have a provider B. I want them to orchestrate or choreograph those specific APIs for my use cases and my needs. I need to then to speak their language. But the heavy lifting, the heavy work lies with me. I have to do all of that work, okay? Because you have these opinionated APIs, and that's a bit of a problem. One thing I wanted to say, though, is that in the end, since you're doing all of that heavy work, what if there is a way then to get around that? What if there was a way to make these providers speak the same language? Surprisingly, though, when you really look into it, you'll see something interesting. In that stack that we've just talked about before, when you look very closely, there is already a common denominator, And cloud native has already changed that landscape to some extent. The open source foundations are driving that change. There is a paradigm shift in that regard, So therefore, managed service providers that offer these services, that we've seen in the continuum, as well as consumers, are primarily already using Kubernetes, So when you really think about it, is that how do we solve that type of challenge? And it says, how do we solve one of the key concepts that is mentioned in the cloud edge continuum, how to overcome this so that we have an interoperability between these providers? When you think about it really well, there's no need to invent some sort of new way. You're already using it. We're talking about here about having Kubernetes with KRM as a representation for a standardized interface to order these digital services. You have these representations of those services that you can then manage in some sort of a control plane. We're not talking about Kubernetes as container orchestrations. No, we're going beyond that and saying is that actually I want to use the Kubernetes API to manage specific states and lifecycles of services that I want them to order as part of a control plane that I can have. And thereby, using KRM as this, you can have these digital twins representations. This means that, of course, the service provider has a representation of the workload that is then ordered, but in a harmonized control plane where all of those things are together, they will then have some sort of CR that represents that state, that order that has been manifested on the provider side of the service. So the point of this is that you have a service capabilities that then become, as part of these digital twins, a live declarative contract between what you get and what you want, and bridging the gap between the different cloud providers. And of course, as part of that, you need to have some sort of way that says that, well, how would I do this with Kubernetes? Well, you need some sort of logical cluster. You need to have some sort of control plane. And this is where we're also using KCP project. And just to reiterate a little bit of the motivation, we wanted to have a motivation and vision going forward that to provide this multi-provider cloud continuum as a mesh, where these providers expose their capabilities through this unified interface. So when we say that, well, like Kubernetes, we want it to be API-centric, not API-driven. We want to have this declarative management of digital twins. I want to define a desired state, and I have that state represented in my control plane that I can then manage the lifecycle of it. And then we also then want to have some sort of choreography over it. So, you want to have multiple separate resources and abstractions and controllers that collaborate together to achieve a desired behavior without necessarily a central orchestrator in the place. And of course, we want to have Kubernetes resource model as our unified language, our lingua franca. And we want then to automate these life cycles of these. So for example, you have an operator that is based on installation and updates procedures that then shift this responsibility of this lifecycle management to product-specific operators. So if you have a service that you order it, that workload that happens on the MSP, those operators are controlling that for you. Now, with that said, I want to show a short demo. The demo is actually in two parts. I've been given some feedback. It's a little bit tricky sometimes to follow, so I'll try to explain a little bit more detail. What we're going to do is that we have an instance of the platform mesh. And through that, we have a Kubernetes API that allows us to order specific services, so these managed service providers. One of those managed services that we have seen actually is an offering of a database as a service. And I can create a manifest and then order that database as a service. I can order it through the CLI, I can also order it through a UI, OpenMFP, or whatever. But then what I will also do is that, well, I have ordered different service providers. I will also then additionally order a Kubernetes as a service. I can then orchestrate my own sort of workload on this cluster. And then I will deploy an application onto this created Kubernetes cluster that then communicates to this database as a service. Now, this is something, it's not a real leap, but what it's really doing is that what you don't see is these two services come from two different service providers. We're talking about provider A, completely different infrastructure, completely different region, completely different API, completely different opinionated way to do this, and provider B that says that I offer you Kubernetes as a service, how you use it is up to you. And of course, you can do rinse and repeat this many times. And the simplest example that we sort of start off with is, what if I wanted to order a simple, very basic example like HB-bin? We all know HB-bin as developers. We want to use it as a sync against some APIs with some testing and so on. Well, how would I order that? So what you do is that this is actually an instance of the platform mesh. We are using the OpenMFP here for the UI. We have these control planes. These are tied to an account in the platform mesh instance. You download your kubeconfig that connects to your account. With that, you're then able to order your resources that we just talked about. So we'll start off with ordering a very basic resource. In here, you see some other references to other technologies. Don't be confused by that. This is just saying that whatever speaks kube, we can use. So we are using things like Crossplane. We can also use Crow. We can also use anything else that is in the ecosystem in here as well. But what we want to do is that I've just ordered a HB-bin as a service, and now I can manage that instance. This is my digital twin representation that I have. The HB-bin itself is running somewhere else on a provider. That provider may not be in the same company. It may be somewhere else. It just goes across the internet. It can be able to be running anywhere. It can also be running on the edge if necessary. but I have that representation in my control plane available for me. Now I do the exact same thing again, and I'm order now a MongoDB instance. And here we see, we're ordering it from Kubernetes. They offer this as a service. It's a hypothetical service. And we said that, OK, now I want them to consume this service. Likewise, I'm now going into a third provider, which is the SAP BDP, where I can also have in there an instance of a managed Kubernetes cluster, which is known in SAP as Schema. You can also have Gartner, but we'll focus on here as an instance in Schema. But the point here is that now I'm talking to my third provider that I'm orchestrating a different API, yet again, all to the same control plane, and I'm just waiting for those orders to be fulfilled by the managed service providers. It takes some time, of course. Creating a Kubernetes cluster will take some time, and an account as well. So, but eventually it gets there. The account is already ready, and then the Kubernetes cluster takes a little bit. But what you can also see here is that you can have integration directly from the UI into that tool as well. So even when we then created these CRUD screens for the HB bin, you can create your own custom UIs and then bring them into the platform as well. So OpenMFP will also allow you to do that, which makes it nice and engaging for the platform mesh because you can, let's say, here is a flow from one to the next, and how you then also manage these specific resources if you wanted to. So here we see the Schema cluster being created. That's our Kubernetes cluster. It took some time. We've jumped forward. And what we're going to do now is, well, when this cluster got created, I also have a secret that now contains a kube-config that allows me to connect to this. So for my control plane now, I'm able then to speak to that kube cluster as well. The way we do this here in the background is that we're using just crossplanes to orchestrate some of those things, but it does not mean that we use crossplane in the platform mesh. This is just purely for the demo here. I mentioned that because in some previous talks we had this question. So using crossplane, crossplane is just one way to get things done. And we've deployed now the application here. We also deployed some rules to make this accessible. And what we're really doing is that I've created a very simple dummy application that uses the MongoDB as a backend, and then it's then able then to store data in it, like you would any other application would do that. I've created a very simple application here that allows me to create a project and then upload some files into it. So if you remember Mega Upload, it's a cheap copy of that. But you just upload some files, and then you can share those files with your colleagues, but it is saving this information against the MongoDB. And this is not coming of a service instance that comes from the same provider. I know I keep mentioning this, but it's very important, is that it comes from a different provider that has a different way to orchestrate things, and we've just managed to enable this interoperability between those two. Okay? So, coming back then to this picture. So the current scenario is that, today's business reality is that there are these fragmentations. You have these lock-ins, you have these snowflakes. And then teams must master these multiple opinionated platform APIs. So these integrations become these, snowflake solutions. But the only way to continue is that you have to disrupt this. And now I hand over to Marvin.
All right. So yeah, the demo that you've just seen kind of feels like something that you might be familiar with. Maybe you've built something similar with Crossplane, where you order things from different providers, but that is exactly the kind of point that we're making here. It needs to have this integration, like glue code. All of that, is there a Crossplane or Terraform provider? Maybe, maybe not. Is it maintained well? Does it have feature parity with the kind of upstream API? All of these things are, up in the air. And we basically think that is, let's say, not ideal. So what if instead of these specific APIs for each provider, every provider would speak the Kubernetes resource model, so the lingua franca that we're trying to establish here. So then consumers could basically talk to one control plane, could talk to another control plane, and they could order the same they could order the same way. They could order the database that we've seen and the Kubernetes cluster as a service via the same tooling. You just use kubectl or whatever tool you have, but you go to provider A, you go to provider B, you order these things. So And this is basically what we have here. This also means like the same provider can also offer the kind of like same service, and providers, maybe have like provider-specific configuration, because a database at provider A might not mean the same as a database at provider B. But still, if you speak the same language, you can basically start out thinking about what are these kind of standards, like what does a database even mean? And these kind of things can be taken over by standardization bodies. Like this is an effective way, I would say, of saying, okay, like if you want to offer a database as a service, like in the European digital market, what does that mean exactly? But for that conversation to effectively happen, you need to be speaking the same language. Like it doesn't make sense to try to establish a contract if everyone is doing things differently. And we consider the Kubernetes resource model, or like another shared language, basically the precondition for doing this kind of thing. Let's take a quick look at what the Kubernetes resource model actually is and what's the difference to a traditional REST API, because I would say like most service providers are establishing or like are exposing some kind of API, mostly REST, but a normal REST API is kind of a multiplexer. So you have an API server in front. That API server then multiplexes your requests to different kinds of code in the background that like are doing kind of like different operations. So you say, okay, I want to create a database. Okay, then that would call like an operation in the background that runs some code to create a database. These often interact with an internal data store, and that is maybe like a SQL database or something, and with the real world to like establish your database. So what's the kind of difference with Kubernetes? The kind of difference with Kubernetes is that you still have an API server that's still REST, but it has like a declarative pattern to create objects in a shared object space. And you have schemas for these objects, so you can, like, you know what these are like. They are typed, but you can extend as well. And kind of the difference here is, like, I mean, most of you probably have seen this. This is a YAML of like something that you would submit to the Kubernetes API, fairly standard. It has metadata, like a way to identify what kind of API it is, a specification that defines your desired state, like what you want the world to look like, and then you get status as a feedback that tells you what the world is, and you can basically, based on that information, determine, okay, the database I ordered, is that already there? Status will tell me, maybe it will take 5 more minutes for this eventual consistency to actually create my database or my pod, something that is often in Kubernetes. But the kind of difference is that we saw these operations being multiplexed by the traditional REST server that can be an API gateway, that can be in the same code base. But essentially, in Kubernetes, the difference is controllers. Like you probably all have worked with controllers already, and the difference is that controllers work with the same object space that the users are working. They're using the same front door, the API server, to interact with these objects and work on them and do the reconcile loop and eventually bring the real world to the desired state. So there's quite a difference here, I would say, and we think that this is a quite interesting model for service providers, and the language, the Kubernetes resource model in specific, is something that a lot of people have already worked with. And extending this is super easy. So like if you have another kind of like object that you want to offer, some other like service that you're adding, well, then you just extend the schema in the object space, you create a new CRD in Kubernetes terms, and you start a new resource controller that then reconciles against different part of the real world, whatever that means. So let's try to take a look at motivation. So why do we think that this whole idea that we're proposing here is interesting? So I think the consumers, that's like more clear, but still, let's talk about internal developer platforms for 4 minutes. So let's talk about, a unified API for your IT service providers internally. So teams that are providing, for example, database as a service, like what would they do? With KCP in the mix, it could look basically like this. So your internal users, they have their own tenant, kind of like their own accounts in the platform through which they interact with different service providers. So the internal users, they would use a tool like kubectl. They would submit a declarative YAML manifest to the Kubernetes resource model-like API that they are interacting with at the platform. And that is basically an order for a specific app, so like some kind of higher order service that someone in the company is offering. And that team that is responsible for that would pick that up. But the team needs, for example, a database to run that service or a Kubernetes cluster to run that service. Like think of the HTTP bin example that we've seen. And they are not capable of running a Kubernetes cluster itself. They need to go basically to the internal team that is responsible for running Kubernetes. So how do they do that? Worst case, they open a ticket. Best case in our model here is basically they have their own internal tenants from which they then create objects with the other service providers. So that's why KCP being a multi-tenant Kubernetes API is quite important. So in the background, this team basically orders like a couple of other things from teams that are working with them, but not directly, to make sure that they can provide that higher level app that they want to provide. So we think that's quite the good model for internal service sharing. Like you've heard this thing as an enterprise service bus like 10, 15 years ago, and we think that makes, with Kubernetes, with the Kubernetes resource model, it's different because it's like a bottoms-up technology that is already proving itself to be good at these kind of things. And so now, still kind of staying with the consumers for a second, how can they now have this buy versus build debate? So how would it be possible in this model to say, okay, I want to bring in an external service provider? You've seen this basically in the example as well, like someone asking for a database from like an external service provider because you don't have anyone in the company who knows how to, well, run databases very well. So very similar model here. So the teams have like their own tenants, like users have a tenant. But basically what we're proposing is because an MSP, so a managed service provider, would also speak the Kubernetes resource model as this shared language, you can then go and import their APIs into your platform. So the MSP speaks Kubernetes resource model, you speak Kubernetes resource model, and suddenly you have protocols like kube-bind, which we're working on, that basically allows you to import that API as a digital twin into your platform. And suddenly, like buying external services is super easy. So kind of similar, like I want to order something special from your MSP that no one in the company is capable of doing. Well, then, I create that kind of object in the platform. The MSP picks that up because there's like a digital twin sharing to the MSP going on in the background. And the MSP can either go to like a cloud service provider, like fulfill this order like any way that they want to, the way that they would also like fulfill an order from like their classic API essentially. But there's also another model here because suddenly the MSP is part of you, and this is where the mesh is kind of coming in. The MSP could be given the permission to use the internal services, so they could provide their specialized software on top of Kubernetes in your own infrastructure. So the MSP gets their own tenant as well and orders a database, a Kubernetes cluster, and maybe some log access through the platform of the consumer, and then runs the stuff on top of that. So that is kind of like, it's super easy to integrate MSPs that way. So that's kind of like the consumer perspective. We think this is very interesting for the European market because we have a lot of smaller organizations that are specialized in certain topics. We don't have like hyperscalers, obviously, to the same degree that the international market has, but we have a lot of experts that are mostly focused on providing the expert service, not necessarily on providing an API, providing a Terraform provider, providing a cross-plane provider, providing an SDK. Like all of these things take a long of time. So an MSP basically now, if you speak the same language, can easily sell to many with very little cost because this like binding into the platform is like basically for free. It's the same language. So whether like corporate A and corporate B, like they can consume this the same way, and it's very easy to scale this way as an MSP and focus on your core business. In this case, like it would be running databases maybe. So basically same thing, like an MSP could pick up orders from Corp A and from Corp B. Like it's super easy to do this basically if you speak the same language suddenly. And they could use this like a cloud service provider to fulfill these orders, or they can do the same thing basically on both sides. So you can order Kubernetes cluster from provider A, from Corp A, run it in their premises, or they can like order a Kubernetes cluster from Corp B and run the software in their premises. And all of that is fully automated because they all speak the same language. So this makes it very easy, and we think this is why it's interesting to MSPs. So, and this kind of allows you to have a semantic federation, like you're speaking the same language, so suddenly like you understand each other, and you can, as we talked about earlier, like establish standards with each other, these kind of things. We have a couple of basically partners in the ecosystem in the project that are like trying to work with us here, that we are trying to work with to establish these kind of standards. So, and this should be very similar to you. Because like this is the Kubernetes model essentially. Like someone creates an operator, that operator runs the deployment in a namespace or something, and that creates replica sets and pods. Like this is not super. Like this is a Kubernetes model extended to a service-based architecture essentially. And both for providers and for consumers, this unlocks the whole cloud-native ecosystem. Because like all of these things are based around Kubernetes. They speak the Kubernetes resource model, so this API language. And that means it's super easy to bring in established parts of the ecosystem and say, okay, I want to integrate this into my platform. I want to use some upstream, maybe Postgres operator. So like that's not a problem. It speaks Kubernetes resource model, so you bring it in. Super easy, and it gives you like a whole new ecosystem and kind of like tool set to get started. Like all these SDKs that you can use to interact with Kubernetes, you can also interact with your new favorite service provider essentially that way. And that service provider doesn't need to like work on a ton of SDKs and integrations that, you know, is a huge engineering effort. So that's basically our proposal. So we basically hope to get some feedback on that. We know we're trying to do this machine room bottoms-up kind of implementation using technology that's already there, because we know that, you know, there's this famous XKCD comic. Like we don't want to establish a new standard. We want to use a standard that's been in the ecosystem already, that's been proven to work. And we think like after 10 years of Kubernetes, that's a fairly, good thing to say. And yeah, Mirza, do you want to wrap it up?
Yes, of course. So another thing I just wanted to quickly mention is we do also have a NeoNephos community call that's happening today at 4 p.m. So if you're also interested, there's another presentation there. It goes a little bit into more detail as well with one of our architects as well. And I'll be presenting that at 4 p.m. So you're welcome to find on the website on neonephos.org. So thank you very much.
The first one, are all the code made available as open source? As for now, the public GitHub looks like a bit incomplete and partial.
Yes, so the public GitHub is in the process of making those examples that we've just created, like the one with the HB bin, available. We're trying to also build a documentation around it, and you know, the documentation takes a little bit of time, but it is something that is coming. Yes, it's very much on our agenda as well.
And maybe to add to that, so Platform Mesh is also basically a combination of various like open source tools. So basically KCP is open source, kube-bind is open source, like basically the whole, the whole ecosystem.
Runtime,
multi-cluster runtime.
API
so like
sync agent from KCP as well. So we will trying to find a way to make this in an engaging way that also allows people to understand it. Because even when we then start looking into things, there's a lot of things and we don't want to confuse people by just dumping it in one place at once.
Okay. Oopsie. Next one. Platform Mesh looks like Gaia X initial approach. How do you make sure it works out this time?
That's a very good question. So as far as I'm aware with Gaia X, you know, there have been attempts at it. What I think what we're trying to do is that we're trying to build on foundations that already exist, on tools that already exist. We're trying not to do it necessarily from scratch. And I think that the Kubernetes API is probably one way to achieve that. It might not be the perfect way, but it's a good stepping stone to build a foundation on top of. Maybe Marvin, do you have an opinion?
Yeah, no, I mean, I think it's exactly what I said in the end. Basically, we're using technology that's already out there. I think a lot of these like prior approaches might have, you know, tried to like build a new standard. Which, you know, is always challenging to be picked up. But this thing, like you have the tooling for that. All of you have kubectl installed already probably, so you can start using that today, like more or less. And I think that's the difference. We're starting from technology that like a lot of people in Europe are already using. You saw how Kubernetes is like has infiltrated most of your stack. So it's familiar technology in a way.
Next one. I'm a cloud provider. Why should I implement Platform Mesh so that my customers then can move away from me more easily, which is in conflict with my business model? Well, that's a tough question.
I mean, that's a good point. So to some degree, like as we've said, like we think that the European market works differently. So we have more of these small providers that are, specialized in array. The other reason is also that like the legislative situation in Europe, is changing and is different. Like you are supposed to allow moving between cloud providers. That's a requirement that you have.
The Data Act.
Yeah, that's the Data Act. So, it's this will help you fulfill these legal requirements easily, while being part of an ecosystem and attracting people through that.
Yeah, I mean, I also want to say is that it's a very good question, but think about it is that, are you going to be able to provide every service that customer wants? I don't know if that's possible. You might want to say that, why can't I make it work? And says, I don't have this service, but if you use that other service, I don't have to say a specific provider or this other ones, whatever, anything sort of database as a service, I'll make it easier for you to work with my tools then.
Another great question. Almost everybody uses some sort of services from the US hyperscalers. You think you'll get those on board? Otherwise, migration might not happen.
That's another tough question.
Yeah.
So the point here was that we're trying, as strange as this sounds, coming from an Australian, we're trying to build something for Europe, okay? So the idea here is that we want to have a way, as part of this Cloud Edge Continuum, we are being sponsored by European funding, European money, to build something for Europe within Europe. We do, of course, do not want to build the next hyperscaler. We want to have these frameworks that allow us to build platforms and services. If you have that mindset that says that I can only use hyperscalers, you can also, abstract their APIs and bring them into the mesh if you wanted. You have cross-planes. Support model it works with KRM. But you could also say that, hey, there are other providers that allow me then to meet also European legislative standards that I want to meet, like the Data Act. That says I want to be able to switch from service provider to another service provider, and I want to have that seamlessly, and that's something that we want to work towards too.
How does Cluster API differs from Platform Mesh when we look at Kubernetes as a service?
I would say it doesn't differ, like it complements each other. So something that you could absolutely do. So Platform Mesh is more like it doesn't really matter that, or like it doesn't care that much what kind of service you offer through it. It's more the approach that you can take. So if you want to offer Kubernetes as a service, you can offer a cluster API through that. Like that's absolutely possible. And then you're a service provider and you allow someone to bind to your implementation of cluster API, and then they can consume that from their own control planes maybe. So it absolutely, it's one of these services that you can offer through Platform Mesh. Platform Mesh doesn't have like a doesn't have a really good idea of what you're trying to offer because it's generic enough for that. It's just the language of ordering things, basically. And that might be a cluster, yeah? Why not?
Who provides the control plane cluster? Where can I order the services?
Yep.
Yeah, I can have a crack at it. So it's essentially, you think of it as a framework to build a platform. You can then create your own instance, okay? If you're a business, you can then use it to start building marketplaces around it and offer services, multi-marketplaces that already exist. Import existing other marketplaces if you have some sort of collaboration with them. That's also possible as well. But it's not a product that we're sort of trying to build per se in terms of, that's only offered by one provider, that they can use it. Anyone can then use it and build it,
I think it's also so the answer to that question is it depends. Your service provider can offer the control plane through which you're ordering, but you can also run an internal control plane then that uses these binding capabilities to then go and order from that provider. Or you can have someone a third party offering a control plane that is basically a marketplace through which you order from different providers. There are many different ways that you can have these control planes managed through a unified language where you can bind to other control planes.
Question about service broker from Cloud Foundry.
So that's one thing we're actually trying to avoid. So the service broker, yeah, so we're not trying to go that way. We're trying to specifically overcome this issue and says that, okay, we want to use Kubernetes resource models as a defining way to do this, and then order these APIs through the mechanisms that KCP then has as well. It's a good comparison, but I think the service broker API is not what we're targeting here, and I think we want to go beyond that.
I think it's basically how to say this, like an attempt at solving the same problem, but hopefully in a better way, in a more successful way.
Exactly. Yeah.
Another question about secure connectivity with various meshed services from various providers.
So, yes, I know we're still starting in that aspect, but think about it, what we've shown that slide with all the different tools. How would you secure a Kubernetes cluster? How would you make this available? Well, it's the same thing, I'm not saying that you need to use some specific tool that only we're going to develop. No, not at all. You use the same security tools that you use with a normal Kubernetes cluster.
Yeah, I think it's basically what would a peering standard look like? Like if you want to peer network A from provider A with provider B's network, that's to be determined. But if you don't speak the same language, then you can't even start with thinking about that. That's the kind of standardization bodies that I mentioned earlier.
Yeah.
Platform mesh reminds me a lot of Seca. How are both related? Are you already in exchange with other to join forces?
I'm not aware of Seca, apologies.
Yeah, if you...
Come and talk to us afterwards if you're here. Or reach out to us and I'll try to answer it, but I'm not aware of Seca, sorry.
How should you give an SLA for availability for a very meshed platform?
Okay, so there are, let me explain a couple of things. In this NeoNephos, we are part of the IPCEI-CIS consortiums, and there are many different work streams in there. So we're not just trying to tackle these global big issues like this one ourselves. So we are working with other people, with other foundations, with other teams to say that how do we establish this? So as part of the work, we then want to also tackle these issues and also have to investigate how that should then be done precisely. Also at the legal level as well. But it's an open issue that still needs to be figured out and in research and development. But it is not something that we're doing ourselves alone.
We're a little bit after the over the schedule, so let's tackle those three lasts. How does platform mesh relate or is comparable to other IPCEI-CIS initiatives such as EcoFed with similar goals?
Well, as a matter of fact, we're actually working with the EcoFed colleagues. So what we have done also is in one of the other demos, we have an integration where we order virtual machines from them to try and collaborate. We also had a federation workshop where we had both EcoFed colleagues there. We also had other organizations there as well. We then talked about what are some of the common things that we can work on together in this federation concepts, and maybe there's already an issue that's that's affecting us both, and how we can then solve it. Yeah, but it is our collaboration there as well.
Got it. Two last. Will platform mesh also provide operators of the respective providers, or is it up to the poster cloud providers to implement them?
So because we are an open source initiative, we try to provide the examples and the means, and essentially you think about the framework to do so. If you want to have a specific integration of provider, you will have the tools to do that. But we will not necessarily have the resources and says that we're going to provide an operator for everyone.
Yeah, and to add to that, to some degree, operators for specific cloud providers are essentially solving this exact problem that everyone is speaking their own language. If everyone speaks the same language, if you can natively order from a service provider, then you might not need an operator. You need then a generic tool like kube-bind to order from that, or you use kubectl to do that. But operators are solving a problem that we think are replacing with this. So
Yeah, and there's also the KCP sync agent as well, and where you can sort of sync these resources from a KCP workspace, from this logical cluster, into the workload cluster. So if you're already an MSP that already has an operator that exposes CRs in a public sense, you can then sync those already without having to do much modifications. Or alternatively, you work on what Marvin and Stefan talked about yesterday, the multi-cluster runtime, on how to enable interoperability between multiple clusters. That's actually also very interesting.
All right, last question. So should platform mesh be a specification and not an implementation?
So there is also, at SAP, there is also the ApeiroRA reference architecture that is also a specification on top of the projects that we've seen in NeoNephos. And that goes in that direction. Yes.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.